Many people consider celestial navigation as the #1 proof of the flat Earth, and they could be right, but I still like my long-distance observations. Celestial navigation refers to the practice of a navigator using angles to the apparent positions of celestial objects in the sky to determine his location on the Earth's surface. Celestial navigation has been used for thousands of years by various civilizations to safely navigate oceans and other large bodies of water. Furthermore, nautical maps were built on these celestial angle measurements. Without question, all angle measurements require a flat baseline. Therefore, celestial navigation can only work on a flat Earth. It's that simple. Let's spend a few minutes and watch a couple of video clips to get a better understanding of this evidence. The first clip is an old instructional video from the United States military. Notice that even though the video falsely uses an image of a globe for the instruction, the circles are still flat, which is impossible on a globe. The second video comes from the channel Mitchell from Australia. The third clip is from Rob Durham's channel, and the last video is from Nathan Oakley, 1980, and Flat Earth Debate. Enjoy!
An important conception for the navigator is the circle of position. It is still another way of showing the relationship between the observer's position and the geographical position of the celestial body being observed. Zenith distance is the radius of this circle. This navigational aid can be illustrated easily. The top of the pole represents a star under observation. The base of the pole represents the geographical position of that star. The length of tape along the ground represents the zenith distance. To see the top of the pole or the star always at the same angle or altitude, the observer must stay on a circle. If the radius is lengthened, the altitude or angle of observation is decreased. If the radius is shortened, the altitude is increased. The navigator's circle of position, however, is on a much larger scale. To repeat, its center is the observed celestial body's geographical position, and its radius is the zenith distance between the geographical position and the observer's position. Obviously, an observer at any point on the circle will observe the same celestial body at the same altitude. Therefore, an altitude, say, of 62 degrees and 33 minutes for a particular celestial body must be secured from any point on a definite circle. But the question that confronts the navigator is, at what particular point am I? To answer this, he constructs another circle of position for another body observed at the same time. He can be on both circles at only 2 points. The two intersections of the circles are normally so far apart that one may be disregarded because it is obviously incorrect according to his dead reckoning.
Every star in the flat celestial plane has a position relative to our flat plane where it will be 90 degrees. This is called the geographical position, or the GP, of that star relative to our flat plane here on Earth. When the observer is at the GP of the star, it appears 90 degrees above their head. Celestial navigation works by using a sextant to measure the angle of that known star and using its relative GP, geographical position, to know where you are. And I'll continue to point out that measuring angles to celestial bodies only works if we are on a flat plane. Now, if one observer measures 30 degrees to a star and another observer measures 30 degrees to that same star, we can conclude that they are both on what's called a circle of equal altitude. And this is another killer blow to the globe right here. Everything on that circle of equal altitude is exactly that, equal altitude. No matter where you are on that circle, you're going to measure 30 degrees. And through being able to measure an angle to that star relative to the horizon, everything on that circle, in between that circle, in the area of that circle, is absolutely flat and level. By doing this once with a sextant, you know you are somewhere on that circle of equal altitude. To triangulate your actual position, you need to repeat these steps with other stars. Your position is where all these areas of equal altitude meet. This is how celestial navigation works and has always worked on our flat, level plane. So if observer A measures an angle to the star, and observer B measures an angle to the same star, both angles are the same, 30 degrees. Knowing the GP of that star, they can conclude that they are on the same circle of equal altitude. Distance between observer A and B and the area inside that circle is all in the circle of equal altitude. It is all flat. It is all the same level. This is the killer blow to the globe. Not only is our world observably and obviously flat, it is measurably flat. Look at this map with all the GPs of the navigational stars on them. And the reason why this is the number one flat Earth proof is because using just one area of equal altitude proves that that large area that we're navigating on is absolutely flat. But by doing this multiple times to create multiple areas of equal altitude, we can literally measure our entire world as flat. Just so you understand the enormity of this proof, we can literally measure our entire world as flat. We are living on a flat Earth.
Now, in order to do a triangulation using a sextant, we use the Mercator projection map as shown here. So we all know that in order to do a sextant triangulation, you need to use a nautical almanac to give you the zenith of the celestial bodies, and you draw circles of equal altitude from that zenith to determine where they cross, and hence where your location is. Okay, to briefly touch on what the guys over at Flat Earth Debate have been saying, we're going to use the exact same examples of the GP positions here. I'm going to look at it from an orthographic view. Okay, if we're standing here on the Earth, this is the angle to the celestial body. Let's take a line from our position, representing the horizon. The angle formed here is definitely not 90 degrees. And even at the position where it meets the Earth, you can't have a 90-degree angle to a curved surface.
My general view of why celestial navigation would be put forward as the number one flat Earth proof is because it's the heart of our statement, all roads lead to a flat Earth. It's based on elevation angles, and elevation angles are the origin measurement of all of our mapping and charting of the known territories. The expansion of the known world, so the reason we can argue against there being no need to speculate about ice walls when we've utilised elevation angles and the geographic positions, ground positions of the stars on a flat plane with elevation angles to expand the territories. So they are the heart of our current 2024 argumentation in terms of all roads leading to a flat Earth. The reason you can launch forward as a flat earther on the front foot talking about flat Earth is because we measure Earth flat. And elevation angles for celestial navigation, as described on screen now in this diagram, is what you do with them. You're measuring angles to a star with a flat baseline and a 90 degree at the ground position of each star to find where you are on Earth if you get lost. The only reason you can do this on the maps is because we have utilised these angle measurements to plot the world we now map. It's part of the systems that we use to measure the stars in the first place. With these angles, You can stop yourself from being dead. You can stop yourself from dying at sea if you have the means of measuring the angles to find where the hell you are and not die. Or to put it another way, the globe is derived from flat Earth elevation angles used in celestial navigation. But for the fact that we measure Earth flat with these angles, you wouldn't have a globe to believe in. Earth is measured flat. Earth will always be flat. These measurements prove it. Celestial navigation proves it.
Nathan Oakley, 1980. Follow his, he does flat earth debates every day. Nathan Oakley is my favorite right now. I love Nathan Oakley.
Yeah, me too.
He demolishes people.
Absolutely.